All right, folks, this is the 8.5 factoring section. This is actually one of the most important things that we're going to talk about in this kind of last 9 weeks of the course, because of how much this is used beyond this class. Okay, you're going to do this. This is most of college algebra, most of algebra 2. Is going to involve you having this understanding. This whole chapter has been about factoring. This is going to be one more tool for factoring, and it's a special case. Okay, and what we're looking at for the most part are trinomials, like maybe like an x squared plus 5x plus 6, or maybe like an x squared plus 9x plus 20. We're looking at things like this. Okay, where in each one of these, the number out in front of the x squared is a 1. Okay, so what we talk about in 8.5 is only going to work for things like that. If it's a 2 out in front, like something like that, or any other number other than 1, this strategy does not work right away. Okay, so that's the plan for this section. Now what we're going to do is we're actually going to work backwards. If you remember in the last sections, we did something like this. If I have x plus, let's just go, I don't know, 6 and x plus 7. If I FOIL that, I get x squared plus 6x, and then we'll multiply these against 7x, so it ultimately becomes a 13x, and then plus 42 when I do last times last. Okay, so we've been working on taking this pair of binomials, which we remember these are factors because we're going. What we did was we just multiplied. Okay, multiplied or FOILed to get to this. Today's lesson is the first time that we're going to actually take this, and remember this is a product because we multiplied to get it. We're going to actually work our way backwards. We're going to start with this thing and see if we can rewrite it as the x plus 6 times the x plus 7. Well, if multiplying was what got me this way, then division is what is going to get me the x plus 6 times the x plus 7. Okay? And if you remember, if I have a product, I'm going to give you a composite number like 12. If I have a composite number like 12, and I say divide it by 2, it gives you 6. So what does that do? That just generated 2 factors of 12. That's what's going to happen here. If I take x squared plus 13x plus 42, and I divide it by x plus 6, it's going to produce the other factor of x plus 7. So when we go through this route or this procedure, we're essentially doing division, but the terminology that the textbook and really any other course or program that you use that talks about this is going to call this factoring. Okay? Whenever we're doing division and we're getting whole number results, we usually call that factoring. Okay? So kind of scrolling through here. I'll let you guys read this here. What I just talked about is really that in a nutshell. Okay, and what I want to get down to is just some examples here. Okay, this example is going to allow us to recognize the pattern that is going to be used when we get down to these examples down here. Okay, so here is the pattern. Okay, what I want to do is I'm actually just going to start with the foiling technique here. Okay, so if I go x times x, so first times first gives us x squared. Okay, outside times outside gives me 3x. Inside times inside gives me a 2x. And then last times last gives me a 6. Okay, if we look at this, okay, I'm going to look at those two. I'm going to rewrite this a couple different ways. I'm going to get x squared plus, now if I group these two like I did, I can actually bring an x out. And I get 3 plus 2 there. you distribute that x, you still get 3x plus 2x. And then I'll put my plus 6. Now, obviously, we would probably most comfortably write this as x squared plus 5x plus 6. Okay? I'm going to go through this next example and see if the same thing happens. First times first gives me x squared. Outside times outside gives me 5x. Inside times inside gives me 4x. And then last times last gives me 20. Regrouping those middle two and pulling an x out gives me 5 plus 4 there, and then plus 20. Well, we know that 5 plus 4 turns into 9, so I get x squared plus 9x plus 20. Okay? What I want you guys to see is, do these two numbers, first of all, do they add to give you that 5 right there? And do 3 and 2 multiply together to give you that 6? If I look at this, do those 5 plus 4s, do they add to give you that 9? And do they multiply 5 times 4 to give you that 20? Okay? So we're looking for numbers here. I'm going to put plus signs there, and a multiply sign there, and a multiply sign there. Those will make sense here in a moment. Down here, I'm going to see, now instead of using 2, 3, 4, and 5, or any numbers I want to, let's say A represents any number in the real number system, and B does as well. If I FOIL this, I get x times x gives me x squared. X times B gives me xb. Okay, now A times x, I'm going to write this way, xa. And then A times B gives me AB. Okay? I'm going to group those middle two. Again, just put parentheses around these two. And we can see that they both have an x in it. So let's factor that x out. You've done that factoring before. Okay? And then I get plus AB. So this is the general practice or procedure that shows there should be, when we're doing this, there should be, when we get this trinomial here, there should be two numbers that add together to give me the coefficient of x and multiply together to give you what we call the C term. Okay? So this is a practice that is always going to work. So what I want you guys to understand is what we're going to go through here in a moment. The set of steps that I give you, the procedure that I give you, is recognizing that this pattern exists no matter what these numbers of 2, 3, 4, and 5 are in these specific examples. Okay? So what happens here is that this is going to be, again, in this format where we've only got x squared plus bx plus c as our trinomial. The number in front of x squared is going to be a 1. Okay? This number here, the b is going to be a number. Okay? Any real number that we want it to be. It's the coefficient of our middle term, or x to the first power. And this c here is a constant. There's no variable there. Okay? Anything that is not of this form, okay, cannot be factored using the technique that we're using. So if we were to have something like x to the third plus x squared plus 5, that is not this form. You see no x cubes here. Okay? If we had something like 2x squared plus 3x plus 12, it's closer, but notice that that 2 right there is not this one. Okay? So every single problem that we do right now, I've already done these examples, and I'm going to attach this to the end of the video. Every one of these, there's a 1 right there, right there, right there. Okay? It's the only way this is going to work. Alright, so when we look at this first example, remember the 15s are C, the 8 is our B. We're going to try to list our factors of 15 because we're looking for numbers that multiply together to give me 15 but add to give me 8. So those numbers, obviously 1 and 15. and then 3 and 5. Those, like, these are groupings for 1 times 15 gives me 15, 3 times 5 gives me 15. But if I add these, that gives me 16. I add these, that gives me 8. That's the one I was looking for because of that number right there. Okay? So once you find, this is essentially finding our factors that we're needing. So this is the approach that we go with then. Okay? You're going to write X there and X there in your set of parentheses. Okay? And then whatever these numbers were are going to be the second part of your binomial. And because there's no sign, we assume that they are both positive. So this will become a plus 3, and this will become a plus 5. And that then is the reverse of foiling. Notice, previously, we would have started with this side, and we would have foiled. First times first gives me x times x, x squared. Outside times outside would give me 5x. Inside times inside would give me 3x. And then last times last would give me 15. And you can see that would give me that 8x there in the middle. So that's kind of a quick way to check to see if I've factored it correctly, is actually just to undo the factoring through multiplication. Okay? But that then is the answer that we're looking for. So that's how we factor our first trinomial here. Okay? Again, you can check this stuff using Desmos. Okay? Maybe we go through the graphical idea, and you're going to get used to these graphs in the near future. So you get something like that with what the problem started as, and then when I factored it, let's see if they give the same graph. And they do. So that tells me, that proves to me that these two expressions, because they're giving me the same graph, those two expressions are the same. They just, one is we call this the product. That one's the one that's all actually multiplied out. That one already had foiling done to it. And this one would be the factored version of it. Okay. Sometimes they call this the expanded version. They call this the factored version. So let's do this next one. Next one's a little bit different because we've got a minus 11x here instead of a positive number. Okay. Think about, we're trying to get numbers that multiply together, give me 24, and it's a positive 24, but add to give me a negative. Okay. Well, the only way that I can multiply numbers to get a positive is if they're both positive or if they're both negative. If both my numbers are positive and I add them together, I'm going to get a positive. A positive plus a positive is always a positive. So that logic says then that the factors I'm actually looking for that give me positive 24 as a product and a sum of negative 11, the numbers are actually both going to be negative. Okay, so just kind of listing the factors, negative 1 and negative 24. Those multiply together give me negative or positive 24. Let's go negative 2 times negative 12. And I'm just coming up with these factors by taking 24 and start dividing it by values. So if I take 24 and divide by negative 3, it's going to give me negative 8. If I take negative or positive 24 and divide it by negative 4, it's going to give me negative 6. The next one would be negative 6 that I try, but that's going to give me negative 4. So now you're going to start to see that one there is actually the same as those two factors. So I don't need to go any further, okay? Because I'm just going to get, so I'll get eventually negative 8 and negative 3. I'll get negative 12 and negative 2 and negative 24 and negative 1. And it's because multiplication is commutative, I really don't need to look at the rest of these because they are the same as these ones up here. All right, so now I'm going to go through and I'm going to add these numbers. I'm going to add these factors. Okay, so we've got, add these together, I get negative 25. Add these together, I get negative 14. Here we get negative 11. And here, I guess I don't even need to go, I guess negative 10, but I don't need to go that far because negative 11 was the number that we were looking for here because that was our B term. Okay, so I'm going to rewrite this as x in that first part of my binomial, x here in my second part, and then those factors. So a minus 3 is there, and then a minus 8 is right there. If you were to FOIL that, you're going to find out that you get back to that thing right there. Alright, so now we're working on this next example. Again, now we're looking at negative 15. Okay, so the only way that I can get a negative product, remember these are multiplied, is if one of my numbers is positive and one is negative. So in this case, I'm actually going to need kind of duplicates, because I'll need 1 and negative 15. Those will multiply together, give me negative 15. But it could also be negative 1 and positive 15. I'm going to go through, okay, 3 and 15, or 3 and 5 are my next ones. So 3 and 5. If I make that one negative, that'll give me negative 15. But I could also try negative 3 and positive 5. Now going through and adding these, this gives me negative 14. This gives me positive 14. This gives me negative 2. This gives me positive 2. There's the one I want. I wanted the positive 2 right there. So these are my two factors. So writing my parentheses, it'd be x and then the minus 3. It would be x. Remember, this is a positive 5 there. So it'll be plus 5. Jump down to the last one. Okay, we get negative 5. The two numbers are multiplied together to give me negative 5 and add to give me positive 3. So negative 5 is kind of an odd number. Okay, and the fact that one, it is odd, but it's also prime. So negative 1 and 5, and then negative 1 in positive. Sorry, negative 5 and positive 1, and then negative 1 and positive 5. Those are my only sets of factors here that would work. Well, if I add these together, negative 5 and 1 gives me negative 4. Negative 1 plus 5 gives me positive 4. None of my factors are going to give me that number right there. Okay? So what we do is we write that this is prime. Okay? Now, just be careful. It's not because that was a prime number. It was because I couldn't find any of those products of that prime number to add up to give me 3. Okay, so just be on the lookout for those. If you can't find factors that work, chances are maybe you've got a prime situation. Okay, what we're going to learn in the upcoming chapters is that I can still target this, much like, just take like 15 divided by 7. You can do that. You can do 15 divided by 7, but it's not going to give you a whole number result. We can factor this thing. It's just not going to be really clean and nice and easy as maybe these other examples here. My plan for you guys so this is Friday's video. I'm going to post something on Monday practicing more of this stuff. I think this is a very key concept. Factoring is your number one tool in a lot of equations that you're going to see in the next several courses. So this is going to be something that you rely on heavily. So I want to make sure that we're functioning within it at a heightened level. So that's kind of the plan as we move forward.